In this tutorial, we're going to explore some more advanced techniques to simulate water and building reflections with the Google Earth Studio animations. Using a tool developed by Elie Michel, we're going to extract 3D models from Google Maps and combine it with our Google Earth Studio render and data within Blender. This technique is using the 3D city models obtained through the Map Importer tool to cast reflections and aid masking when applying our own 3D models to the Google Earth Studio animation. From a compositing perspective, 4K renders of Google Earth Studio provide a higher quality render when compared to the 3D models imported into Blender. This is primarily due to the optimization algorithm that is used by Google in rendering the images. We can, however, enhance the quality of the render using the 3D model by adding reflective surfaces, additional 3D models, and camera effects. In this tutorial, we will be importing the Google Earth Studio rendered images into Blender, acquiring 3D maps, models, objects, aligning and overlaying the objects with the Google Earth Studio render, applying reflective surfaces, and compositing the various layers within Adobe After Effects. I'm going to start off with a pre-built project of Singapore. This project includes flying over the harbor of Singapore and revealing the downtown core, and then pulling back to reveal the Ferris wheel and the Garden by the Bay area. For the first few frames of this animation, I'm going to have an overhead view that I'll use to align our 3D models. Ensuring the top is north with the pan set to 0 and the tilt also set to 0, we will have a few frames in the render to align within Blender. Switching to a top view to show the track points. The various track points will be used for placing 3D models in Blender. I'll be adding an additional track point to aid in aligning. I'm going to find a distinguishing location in the top view using satellite imagery to place a master track point that will be used to align our 3D model of the Singapore cityscape. This point right here on the peninsula should be a good spot to use. I'll now right mouse click and select Set Track Point, and I'll just confirm the coordinates and the altitude, and I'll name it Master. Since I've already rendered the images for this animation, I'm going to use the export function to extract just the camera data information, and I will overwrite the existing JSON file. This file will now include the additional master track point that we just added. Now switching over to Blender, I'm going to load the script that will import the Google Earth Studio data. And I'm going to run it with modifications for the file locations. And again, this script is available on GitHub with the link in the description below. And so it all looks good there, so we'll click on Run Script, and as you can see it has completed. We have a new object in the collection called GES World, which contains all of our information with regards to track points and camera data, as we can see here. Now just jump over to Chrome, we'll save our file that we modified, and we're going to close the Chrome window. We're going to use a tool to import 3D models of the Singapore harbor. So jumping over to a folder I've created on my system, we have Google Chrome with startup extensions and an application called RenderDoc. We will use these two tools to capture the three-dimensional data from Google Maps and extract it into a file format that can be used in Blender. There are several videos on YouTube explaining this process and how to install the add-ons, and I'll provide links in the description below. I use a slightly different technique to extract more high-resolution mesh and image data, and I'll show you how that's done here. First, we'll double-click on the Chrome application with the startup extensions, and a pop-up window will open with the process ID number. We'll remember this number because we'll need it when we use RenderDoc. We'll then open up RenderDoc and go to File, Inject into Process. We'll now type in that process ID, and we'll see that it's associated to Google Chrome GPU. We'll select that item and then click on the Inject button. Switching back to Chrome, we'll close the startup dialog and navigate to maps.google.com. We'll then search for Singapore and zoom in on the downtown core. We'll switch over to satellite view. While there's a 3D button on the side there, we'll actually maintain this particular view because it's an overhead view. You can see that some of the buildings here are actually appearing in 3D. If you move from left to right, you can see the perspective change. So in this top view with the north facing up, we're going to zoom out or down to 25%. This will multiply the amount of information being delivered to the browser that we can then capture with the render dock capture. Switching back to render dock, we're going to click on the capture frames immediately. We'll then switch back over to Google Chrome and wiggle the screen. This will force the information to be pushed to the graphics card. Now looking at this particular file, we're missing the third color pass, and our file size is smaller than expected. So we'll give it another attempt. We'll click on the capture frames now, and then switch back, and we can see now that we have 189 megabytes. We'll double click on that to see the information, and we'll see that we have 3 color passes. So this has been a good capture. We'll now go to File and then Save Capture, and save that RDC file to our hard drive. We can now close the RenderDock application, and then in Chrome, let's reset our zoom level for our next session, and we can close the Chrome window as well. And then we'll switch back into Blender. Go ahead and save our Blender file now as we prepare to import the RDC file. So once that's saved, we can then go to File, Import, Google Maps Capture, and then select the RDC file. We're going to change our max blocks to 2000 since we've got a massive amount of data that we'll be importing. And this should be capable of importing all of the information. And now we sit for about 5 to 10 minutes, depending on the speed of your computer, while it loads the 3D data. With the 3D model imported, we will now organize the numerous meshes into a collection. First by creating a new collection, then selecting the first mesh and shift selecting the last mesh, we will drag into the collection. Each mesh contains a specific section of the overall 3D model. To accommodate cohesive scaling and position, we will group the meshes into an empty object for more precise control. Switching to render view, we can locate the area where we place the master track point. Using the 3D cursor, we will place the origin for an empty object and add an empty object. Now again, selecting all the meshes, we will drag into the empty object, creating the empty as the parent. With the meshes now grouped, we can align the 3D object with the rendered images from Google Earth Studio. Using the first few frames of our render, we can view overhead and move the object to our correct position in relation to the master track point. Then by using the Z or Z value of rotation of our first track point, in this case the track point called Water 1, we will then copy the value and assign it to the 3D model. With the orientation set and the position approximately aligned, we can scale the object in relation to the rendered images. While your scaling may differ, I have found a value of 0.789 can be used for the majority of the projects using this technique. You may have to make manual adjustments for your project. To aid in aligning the 3D model with the rendered images, we will ghost the background image over top of the model. By selecting the camera, then the background image pane, select the depth to front and set the alpha to 0.5. We can now see the rendered image and the 3D model simultaneously. We can now set the Z value for the empty object containing the meshes to 0 meters, approximately the same value as our master track point. Using the camera view so as to display the rendered images and aided by a secondary 3D view panel, We can manually adjust the object to align with the rendered images. Be sure to scrub through the entire project to make minor adjustments to accurately align the images. As the 3D space can be deceptive, it is important to spend time ensuring positioning is correct throughout the full timeline. Once you are confident of the alignment, we can save the project. We'll also reset the background images to their original settings. To provide a more realistic reflection environment, we're going to add an environment map to the project. First, we will select the world properties, then the environment texture. I'll add an image I downloaded from HDRI Haven. It has similar daytime lighting and a nice cloud texture. I'll make a slight adjustment to the strength, and then we'll edit the nodes for the world environment. In the Shading tab, we're going to select the World drop-down to expose the world configuration. We're then going to add the Texture Coordinate panel, as well as the Mapping panel. We'll connect the generated node to the vector node and select Texture. We'll then connect the vector to the vector of the image, and we're going to adjust the Z position by -0.1 meter. This will lower the horizon. With the horizon lowered, we'll only see the clouds in the image once we render it. We're now going to use one of the track points to create the water surface. Since the track points are added as planes, we can just resize the plane and position it to cover the entire water area. As you may notice, the water surface within the 3D model has a number of bulges and is somewhat inconsistent. We will be altering the model to ensure these inconsistencies are not reflected in our final render. To help in identifying the inconsistencies, we will temporarily change the color of the water surface to red. To make the editing of the 3D model easier, we will join the meshes into one. Select all the meshes within the empty, and then select Join from the menu or by clicking on Ctrl-J. Once all the meshes are joined, we can edit the mesh by entering Tab, and then using the Lasso tool we can roughly select the area that we want to alter. Then using the Grab tool, we can lower the surface of the water below the plane that we added. We can then additionally fine-tune the points around the edges of the harbor and buildings. Precision is not critical at this stage, however, we'll try not to be too sloppy with our work. When the point adjustments are complete, we can set up the water material. Firstly, we'll change the color to a shade of blue within the shader editor. We could then add a texture coordinate, the mapping panel, a noise texture, and bump mapping. We'll also slide the timeline up so we can see our adjustments at various frames within the sequence. We'll connect the generated node to the vector, change the mapping type to texture, then the vector to vector, and the factor to height, and then the normal to the normal. Then we can change the scale of the noise texture to around 200 or 300. Adjust the specular to 1 and the roughness to 0. As you can see, the results are somewhat odd. We'll make an adjustment now to the mapping scale to replicate the size of the desired waves. We can then flatten the bump map by adjusting the strength to about 0.1 and a distance of 0.1. I'll make a few adjustments to the color to closely resemble a realistic watercolor. As you can see, the adjustments of rotation on the mapping panel will simulate the movement of waves in the water, so we will add a keyframe to the beginning and one at the end of the sequence to add some movement to the water surface. I'll jump back into the world properties to make a quick adjustment to the rotation of the sky, so as to ensure the light from the sun is correctly positioned. Now, to enable the reflections of the water surface, we will ensure the screen space reflections is selected from the render properties, and you can now see the interaction with the skyline and the water. To add a little more accuracy to the reflections, we will add a reflection plane. The screen space reflections work well in many cases. However, for accurate reflections, the reflection plane will provide more calculations in processing accurately. We'll resize the reflection plane to the water surface and adjust the height for the best reflection of the buildings. In some cases, this is the desired final result. However, for this tutorial, we are going to add reflective glass to the buildings so that they may reflect off each other and the environment. Feel free to skip ahead if you want to omit this step. To achieve this effect, we're going to change the properties of all the materials associated to the mesh using a script. To begin, we'll select the mesh object of the skyline. Jumping to the scripting tab, we will create a new script document and paste the following code. The code snippet is included in the description below. We're going to ensure the specular is set to 1 and the roughness is set to 0. This will create a shiny reflective surface on all the building materials. As you can see, the change exposes the geometric inconsistencies found within the buildings, so we will perform a little surface cleanup to achieve the desired results. First, by tabbing into the mesh for edit mode, we will do a small point reduction. We don't want to change the geometry of the object, but just a little cleanup. We'll select all and then merge by distance. We'll go with 0.001 meters. We are now going to flatten and align the building facades using loop tools. To ensure this add-on is enabled, go to Edit, Preferences, then search for loop tools. Now we're going to use the lasso tool. Select faces on the same real-life pane. Since this building has some horizontal sections that appear off-plane, I will be careful to avoid them. When all the faces are selected for the desired plane, right mouse click and select Loop Tools, then Flatten. We will use the default option for Best Fit. For each building surface you need to correct, repeat the procedure. This technique will only optimize flat surfaces. In this tutorial, some buildings were relatively easy to correct, while others took a little bit more time. The whole process in this tutorial took about 20 minutes. We're now going to add a sunlight to the scene, so we're going to turn on our ambient occlusion, and we'll put our 3D cursor in the middle of the harbor. And now we'll add a light, sun, and then we'll just raise it up a little bit and adjust our angle from where we want our sunlight to come from. And then we'll just adjust the color and the strength of the light itself. And with our lighting set, we can go ahead and refine our mesh's materials. The objective here is to isolate the non-reflective surfaces and adjust the roughness value. We'll be using a script to perform this task. First, select the building mesh and then tab to enter edit mode. We're going to begin by using the lasso tool to select areas where we don't want the surface to be reflective. We only need to roughly select the areas that we want to modify, as they are generally part of a material block as defined by the Google Map models. This script will cycle through the materials for each face that is selected and change the roughness on each of them to 1.0. Depending on the number of faces that you've selected, this may take a few moments. Upon reviewing the changes, some areas may have lost their reflectiveness that you may want to maintain. You can go back and select the areas, and then change the roughness value back to 0. A link to this script is available in the description below. After reviewing the final scene, we're now ready to render. First, we're going to select Filter from our Scene panel, and we're going to toggle Disable in Renders and Hold Out. And I'll just make a little adjustment to the sun value here. We're then going to disable rendering for objects we don't want to appear in the final render. This would include the various place markers that came through in the Google Earth Studio file, as well as the default light, and we'll just organize this list a little bit. For this first render, we're going to render the mesh buildings as well as the water surface. So now we'll jump over to the rendering tab. We're going to be sure our ambient occlusion and screen space reflections are on. We're also going to drop down the film tab, and we want to make sure that the transparent is selected. And we're going to use the overscan, which will aid in the screen space reflections, ensuring that the calculations are made outside of the camera area. And we're going to set that to 5%. And we'll just do a test render here. And then using a timeline panel, I'll check various points within the scene to confirm the render. The first render will be the full render without the sky. The second render will be our masking render, and the third render will be the sky. We will then layer our renders along with the original Google Earth Studio render in Adobe After Effects to achieve our final result. So I'll select a folder, or actually create a folder here on my system, and we will save all of the rendered files into this folder. We'll call this one Render Full, and we'll ensure that we give the file name the full prefix. And I'll just confirm the settings here. We're going to render this out at 1080p, 30 frames per second. And we're going to start at frame number 90. And of course, we're going to be rendering this as a transparent PNG as well. And when that sequence is finished rendering, we'll do our second sequence. So the second sequence is going to be our mask. To achieve the mask effect, we're going to use the holdout for the collection 2 here. And then we'll also want to turn down any lighting within the scene. So we're going to turn off our sun, and then in our world properties, we're going to set the strength to 0 for the effect of the environment. And then moving over to the rendering tab, we'll do a quick sample render to see what that looks like. And as you can see, the holdout on the building mesh subtracts from the water surface, leaving just the water surface as a black object. We'll use this along with the transparent PNG to mask our images within After Effects. So we'll create a new folder and give that the prefix of water. And we'll confirm that all our effects are turned off, including the ambient occlusion, the screen space reflections, and the overscan. This will just speed up the rendering process. And we'll go ahead and render those files. And for the final render, we're just going to disable all of the objects from the render. We're going to set the film transparent value to unselected and disable all of the other effects. We'll save these renders to a separate folder called Sky with the prefix of Sky. This is just going to render the background HDRI image that we will then underlay in our image sequence in After Effects. Once After Effects is loaded, we're going to import our image files. So we'll select right mouse click in the project area and select Import and then Files. And we're going to first import our Google Earth Studio files. So we'll navigate to the folder there and into the footage folder, selecting the first item and import as JPEG sequence, and then click on Import. We'll then import our render from Blender. So this is our full render, and so we'll navigate to that folder, which is Render Full, and select the first and import the PNG sequence. We're then going to import the masking for the water, so we'll navigate to that folder, which is Render Water. Select the first file and import PNG sequence. And then lastly, we're going to import our background sky. So we'll again navigate to the folder, select the first image, and import PNG sequence. Once all the images are loaded, we're going to drag down our Google Earth Studio image sequence to the workspace. Because we rendered in 4K for higher quality, we're going to reduce the size of the image by 50%, so it will target HD. So we'll scale our image sequence to 50%. We're then going to adjust the composition to HD as it brought it in as 4K. So we'll set that at 1920 by 1080 and click OK. Because there are some scaling issues when using masking, we're going to pre-compose the Google Earth Studio image sequence. And so we'll select pre-compose, and then we're going to move the attributes to the pre-composition. Next, we'll add the rendered layer, and we'll put that on top of our Google Earth Studio images. As you can see, our frame sequence is off. We started at frame 90 in the Blender render. So we'll be moving our image sequence to start at frame 90 or 89, depending on the 0 point of the actual files. So we'll find an area where we can see the overlay. Then we'll just zoom in on the starting point and find the start for the images itself. So we'll be moving that across to frame 90 as a start. And we'll just hide it and view it. It looks like we're off by about 1 frame there. And so we'll just check a couple points there, move back a frame, see how we look. Looks like I moved back 2 there. And we'll adjust it until the rendered image precisely lays over top of the Google Earth Studio images. And next we're going to mask the water layer so that we can provide a different transparency or opacity level for the water in addition to the reflections on the building. So we'll drag down our water image sequence. Again, we'll move the start point to 90 along with the rendered image sequence. And we'll be using this as an alpha mask for the rendered image sequence. This is going to isolate our water element. So once that's all aligned, we're going to select the alpha mask, and this will just show the rendered image with the mask of the water. Now we'll make a duplicate of the original Google Earth Studio rendered image sequence, and we'll move it to the top. We're going to apply a linear color key to this, and we're going to select the color as the color of the water. This now again will overlay the images except in the water area. This just helps smooth out some of the edges and gives us a clean layer to add our reflections on. Next, we're going to add our reflective layer. So again, we're going to use the full render. We're going to put it on top again. We'll move our starting position to frame 90. And you can see now that it's applying the reflective surface to the buildings. We want to control the blending of the reflections over top of the Google Earth Studio render. So we're going to use the difference matte. This will allow us to control similar elements and only display the reflective qualities of the render. With our difference matte, we're going to identify the source as the Google Earth Studio render. And we're going to make sure we select the lowest layered item, as that has no effects applied to it. Then using the tolerance, softness, and the blur difference, we'll make adjustments until we get the desired look. And you can see the difference in quality that you're going to be able to get from the Google Earth Studio render versus the Blender render. So what we can do is, in areas where we want to have higher quality, we want to exclude the Blender render and just include the Google Earth Studio render. So we can do that through the various adjustments that are provided here. We'll now apply some transparency to the rendered layer. And now lastly, we'll replace the sky. So again, we'll drag down our sky element. Again, we're starting at frame 90, so we'll move our sky to start at frame 90. We're going to use the set matte effect on this. We're going to use the source for the matte as the full render, as it does have transparency behind the skyline. And we will invert that. And additionally, we will then also make a duplicate of the Google Earth Studio render and drag it to the top. We'll use the linear color key to isolate to the sky also. So we'll just use the eyedropper tool, select the sky color, and we now have a sky replacement. And we'll set our alpha to inverted alpha, and that all looks pretty good. Now, in keeping with the guidelines for Google Earth Studio usage, we want to ensure that the Google Earth Studio watermark is visible at all times. To achieve this, we're going to use our Google Earth Studio render, isolate the white within the render itself, and then mask that over top. So using the linear color key, we'll use the eyedropper tool to select the white, and then using the invert alpha effect, it will display just the white text. And we can adjust our softness a little bit there to ensure that it is just the text. And now we have a top layer of the Google Earth Studio watermark. So this composition is now ready to render. We'll just set our start point and end point for the render. And I'm just going to export it to our render queue. Thanks for watching, and be sure to like and subscribe. Come check us out on our second channel, Magiscope Technology, where we'll be featuring videos on Google Earth Studio integration. Links in the description below.